For this question, we want to use the substitution method or the elimination method to solve the system. We have the equation y equals 5/7 x minus 4. And the second equation is negative 15x plus 9y equals negative 36. So this is a system of linear equations which we're going to solve by either substitution or elimination. So with the substitution method, we like to have one of the variables solved for like we have in this first equation here. With the elimination method, we like to have the setup of the system being that the x's are lined up, the y's are lined up, our equal sign is lined up, and our constants are lined up. And you can see that our x's are not lined up in this example. So because it's not set up for the elimination method and it is set up for the substitution method, I'm going to choose to use the substitution method just because I think it'll take less time. So with the substitution method, you're going to take what's on the other side of this equation and substitute it in for y. That's going to be, so I'm substituting it in for y into the other equation. Now that's going to give me negative 15x plus 9 times 5/3 x minus 4 equals negative 36. I'm going to use the distributive property to distribute this 9, which will give me negative 15x plus 45 over 3x minus 36 equals negative 36. And 45 over 3 is 15, so we have 15x. And I can see here my like terms of negative 15 and positive 15. Those are going to cancel each other out to become 0. And I have negative 36x equals negative, I'm sorry, there's no x there. Negative 36 equals negative 36. So something special happened in the process of solving with the substitution method. All of my variables ended up canceling out or disappearing. And whenever that happens, you know that you have a special scenario related to solving systems of equations. Now with systems of linear equations like this one, we can use a graphical representation so that I can show you what these special cases look like. So a typical system of linear equations will have two lines, and those two lines will intersect in a single ordered pair. And that ordered pair would be the solution to the system. So that's a typical system. For this example, what we have is two lines. Oh, sorry, that's the wrong one. This is the other special case. Two parallel lines, and those two parallel lines never cross each other. And that means there's no intersection point and no solution. And then the third possibility you can get is where the two lines are actually right on top of each other. And that means that every ordered pair on that line is going to be a solution to the system of equations. And that's the one that we have here. Now the reason why I know it's the second one and not the first one is because of this final statement here. This final statement is a true statement. Negative 36 equals negative 36. Whenever you have this situation here where there's no solution, this final statement will be a false statement. So this system of linear equations has infinite solutions. Every ordered pair that's on the line will be a solution. And that also means that these two lines are actually the same line. You can manipulate one to be exactly the same as the other. So when you write the solution to this, you have to write it in a special way because although there are infinite solutions, it's not just any ordered pair, it's only the ordered pairs that are on that line. So there are a bunch of ordered pairs that are in the plane that do not fall on that line. None of those ordered pairs will be solutions to the system. So we want to write down only the ordered pairs that are on the line. So we typically write ordered pairs like this, x and then y. What we're going to do is we're going to use this equation right here, and we're going to replace the y. Leave the x, we'll replace the y with 5/3 x minus 4. So all of the ordered pairs must follow this pattern. We can choose the x, and then the y must follow that pattern, 5/3 x minus 4. Thank you for checking out my videos. Have a great day.